In this video, we are going to discuss the algebra functions and the composition of functions. So let's go ahead and get started. So first of all, let's talk about the algebra functions. So let f and g be two functions. Then the following is true. F plus g of x is equal to f of x plus g of x. In other words, f plus g of x is a new function that you get by adding your two functions. F minus g of x you're going to get by subtracting the two functions. F times g of x, multiply the two functions. And f divided by g of x, divide the two functions. Now one of the things you got to watch out for on this one is g of x can't be 0, because then this fraction would be undefined. As far as the domain of the resulting functions includes all values of x common to the domains of f and g. So look for the domain of f and the domain of g, and whatever they have in common, that's your domain. Now there's one exception. For f divided by g, you must also exclude any values of x for which g of x equals 0. Alright, so let's go ahead and do some examples. So if f of x equals 3x plus 2 and g of x equals x squared minus 4, then f plus g of x we're going to find by adding these two functions. Now you don't really need the parentheses when you're adding binomials or polynomials, so you can just ignore those and combine like terms. Notice, let's go ahead and put our x squared term first, and then we've got a 3x term, we'll put that second, and then the 2 and the negative 4, we're going to get a minus 2, and so that's f plus g of x. On number 2, we're going to find f minus g of x, so we'll subtract the two functions. Now notice here the parentheses make more of a difference, not so much the first one, we can just drop the parentheses there. But on the second parentheses, notice I had to distribute the negative to the x squared and also the minus 4. So that's something you want to watch out for. So here we're going to end up getting a minus x squared and a plus 3x, and then 2 and 4 are going to give you 6. And so let's move on to multiplication. So here we want to multiply the two functions. So we're just foiling here, and those are your 4 terms. And we should probably put them in descending order, so let's move that x squared term. And so there's your final answer for number 3. Let's look at division. So we get 3x plus 2, which is f of x, over x squared minus 4, which is g of x. Now remember, with division we have to watch out. Actually, I'm sorry, we have our answer here. We'll find the domain next. So let's go back and find the domains. Alright, so f of x is a linear function, so the domain is all real numbers. And g of x is a quadratic function, so the domain is all real numbers. We've discussed that previously. So what do these two domains have in common? Well, for f plus g, f minus g, and f times g, it's just going to be all real numbers. Because we're just looking at what the two domains have in common, and the domains are all real numbers. So when we get to 4, though, it's all real numbers except for any values that cause g of x, our denominator, to be 0. So let's go ahead and set our denominator equal to 0, and we can factor that, and you get 2 and negative 2. So you have to exclude these values from your domain for this problem. So finally, let's go ahead and write this out. Negative infinity to negative 2, and then from negative 2 to 2, and then 2 to infinity. So basically, it's all real numbers except 2 and negative 2. Alright, so let's move on. If we have f of x equals 3x plus 2 and g of x equals x squared minus 4, let's do a little different problem. F times g of 4. Now we could do this with any of the functions. We're going to do it with multiplication here. Think about what this means. We know that f times g of x is f of x times g of x. It's the function we get by multiplying our two functions. Now in this case though, we don't have f times g of x, we have f times g of 4. So instead of having an x here, we have a 4. So these values are just going to be replaced with 4. So we get f of 4 times g of 4. That's what f times g of 4 means. So we know how to find f of 4. Let's use the f function. We'll plug in 4. What is that? 12 plus 2, we're going to get 14. So f of 4 is 14. G of 4, we'll use the g function. And let's plug in 4. And that's 16 minus 4, we're going to get 12 there. And so when we multiply, we get 168. And so that's how you do a problem like that. Let's move on to the composition of functions. So this is the one that's a little bit more complicated. The composite function, f of g, the composition of f and g, is defined as, and I just want to look at this right here. This is read f of g of x, or the composition of f with g or f and g. Well, I always say that if you can say this, you can do this. Because, now first of all, this is not fog, although it looks like fog. That's not an O, it's like a small circle. So it's f of g of x, and notice, isn't that how we say this? F of g of x. So if you can say it, then you can write what it's equal to, or what it means, what the definition is. Now, it also has one more part here where x is in the domain of g, and g of x is in the domain of f. So I'll show you in just a few minutes how to find the domain when you're working with composition of functions. So let's look at an illustration of what's going on here. So basically I have x in this set of numbers, and I'm going to plug in an x value into the g function, and my output will be g of x. Then I'm going to take that value and plug it in, g of x, I'm going to plug that into the f function, and my output's going to be f of g of x. So that's basically the idea here. Now there's this composition of function gets us there in one step. So f of g of x is equal, we already said, to f of g of x. A couple of things I want to point out here. Notice here we have this circle represents the domain of g. It's the set of all our x values, the inputs that we plug into g. And then over here, g of x is the range of g. So we plug an x into the g function, our output is g of x. So this is the range of the g function, but it's also the domain of the f function. Because we're plugging these values into the f function, notice the output over in our last set here is the range of the f function, or you could think of it as the range of f of g of x. or f of g. Alright, so that's the basic idea. Really what we're doing is we're plugging one function into another function, and that's the main idea of composition of functions. One more thing I want to point out here is g of x is what we call the inner function. Notice it's being plugged into f. So g of x is g is the inner function, and f is the outer function. That's something that we'll be wanting to remember. Alright, so we're going to let f of x equal x squared plus 2x, and g of x equal 3x plus 1. Let's go ahead and find f of g of x. Remember, we can say it, we need to write it, we need to use the definition. This is equal to f of g of x. Again, we say these two the same way. But what is g of x? Well, g of x is 3x plus 1. So this becomes f of 3x plus 1. So we're going to plug 3x plus 1 into the f function. Think about what the f function does. It squares your input, and then you add to that twice the input. So I'm going to go ahead and write a shell for that. So again, we're going to square our input and then add 2 times our input. So our input in this problem for the f function is 3x plus 1. So now we need to simplify this, so we're going to have to FOIL 3x plus 1 times itself. Notice I distributed there. Let's go ahead and simplify this. You can check my work. You can stop this video anytime you need to. You should end up with 9x squared plus 12x plus 3. Alright, let's do another one here. Let's find g of f of x. So by definition, this means g of f of x. Notice f of x is your inner function here. And we know that f of x is x squared plus 2x. So we're plugging in f, the function f, into the g function. Now what does the g function do? Well, we triple our input and add 1. So in this case, our input is x squared plus 2x. And then now we just need to simplify this. Notice we started with an input of x. Our output is our answer here. Alright, let's move on to the next one. F of g of 2. Well, again, by definition, this means f of g of 2. Well, what is g of 2? We can find g of 2. Since g of x is equal to 3x plus 1, we're going to plug in 2, and we get 7. So g of 2 is 7, so this becomes f of 7. But we know how to find f of 7. Let's look at the f function. Let's plug in 7. You should get 63 there. So our answer on number 3 is going to be 63. Alright, let's move on. Oh, I'm sorry, I've got one note I want to make here. Generally speaking, f of g of x does not equal g of f of x. And you can see that here. These are not the same answers. So generally speaking, these are not equal. Alright, number 4. If h of x is equal to the square root of 2x plus 3, find f of x and g of x such that f of g of x equals h of x. So I need to find two functions that I can compose together or put together to create this function h of x. Well, remember what I said before about inner and outer functions. Remember, f of g of x, by definition, means f of g of x. G of x is our inner function. So we want to call g the inner function. Notice in this problem, the 2x plus 3 is going to be the inner function. It's inside the radical. So that's going to be g of x. Well, we're taking the square root of that, so our outer function, we'll call it f of x, is the square root of x. So let's make sure this works. So f of g of x is by definition equal to f of g of x, and g of x is 2x plus 3. Now when we plug that into the f function just takes the square root of your input. So here your input is 2x plus 3, so we get an answer of the square root of 2x plus 3, which is what we were looking for. That is h of x. So it did work. Let's try one more. If h of x equals 3x plus 4, quantity to the 5th power, find f of x and g of x such that f of g of x equals h of x. So again, actually I would encourage you to stop the video and see if you can figure out what f of x and what g of x and f of x should equal. Alright, so 3x plus 4, that's going to be our inner function, so there's your g. And notice we're taking that value to the 5th power, so our outer function is going to be the x to the 5th, or the idea that we're taking something to the 5th power. So again, if you want to check this, let's find f of g of x. And so we'll plug in 3x plus 4, because that's g of x. And notice we do get 3x plus 4 all to the 5th power. So it did work. Alright, we've got one last problem here to do. Actually, we have a couple of these. So find f of g, g of f, and the domain of each function. So here's where we get into the issue of domain. So f of x equals the square root of x plus 4, and g of x equals x squared. So f of g of x, it's going to be f of, let's see, g of x is x squared. So in the f function, we take the square root of our input plus 4. And so our input here is x squared. So we're going to have the square root of x squared plus 4. For g of f of x is the square root of x plus 4. So what does the g function do? Well, it squares our input, and the input is the square root of x plus 4. Now remember, taking a square root and squaring are opposites. So this is going to equal x plus 4. Alright, so now let's talk about the domain. This is the part we got to be careful with. How do we find, or how do we determine the domain? Now keep in mind that in the definition it said x is in the domain of g, and g of x is in the domain of f. Well, let me give you a nice easy way to do this. 2 steps. To find the domain of f of g of x, first we're going to determine the domain of g. And then step 2, we're going to find f of g of x to determine any further restrictions. So let me show you how that works. So notice here, look at g of x. G of x equals x squared. The domain is all real numbers. Now if you look at our final answer for f of g of x, no matter what x is, we're always going to be greater or equal to 0. Remember, we can't take the square root of a negative number. So, I mean, you could actually set x squared plus 4 greater or equal to 0. X squared is greater or equal to negative 4. Whoops. Now keep in mind, if you square a number, isn't it always positive, or it might be 0? So you're not going to have, it's always going to be greater or equal to negative 4. So in this case, because x squared is never going to be negative, we're never going to have to worry about taking the square root of a negative number, because 4 plus 0 or any other number that would have to be positive, we're going to be taking the square root of a positive number. So in this case, our domain is going to be all real numbers. Let's go ahead and look at g of f of x. Now I have to be careful, this is the opposite because it's g of f of x. So first of all, we want to look at f. What's the domain of f? Well, square root of x plus 4, we need x plus 4 to be positive or 0, so we set x plus 4 greater or equal to 0. So our domain for f is x is greater or equal to negative 4. Now if you look at the output, x plus 4, we don't have any further restrictions. So this is our domain, x is greater or equal to negative 4. In interval notation we write negative 4 to infinity. Alright, let's look at one last example. So on number 7, f of x equals 2x plus 5, and g of x equals 1 over x. So f of g of x is equal to f of g of x. G of x is 1 over x. So remember, with the f function, we double our input and we add 5, or you can see that's what's going on here. And our input here is 1 over x. So this is going to be 2 over x plus 5. Think about what the domain would be. Now here we want to look at g first. That's this function here. Notice x can be anything except 0, and that's also true here. So that is going to be our domain. So we said x can't be 0, which means our domain is going to be negative infinity to 0, and then from 0 to infinity. So g of x had a domain of everything except 0, and if you look at f of g of x, it's got the same restriction, x can't be 0. Alright, let's look at g of f of x. So here you're going to get g of 2x plus 5. So the g function is 1 over your input, which in this case is 2x plus 5. So that is your answer. So in this problem, first of all, we want to look at f of x. The domain here is all real numbers because this is a linear function. However, if you look at g of f of x, we've got to make sure that we don't have 0 in the denominator, so we need to find out when 2x plus 5 equals 0. We're going to get 2x equals negative 5, or x equals negative 5 halves. So it's all real numbers except for this value here. And that's how we would write that. And that's it for this lesson.